Okay. On the screen, you can see that this is a combination after the add between two signals, the source 1 and source 2. Can you turn on the light? Turn on the speaker. And you can hear the sound from the speaker. After adding the two signals together, I put it on the audio sync, and that's the sound that you can hear. Also here we have the FFT sync and also the oscilloscope sync. As I talked to you, as I mentioned in the graph on the presentation. And now I'm going to talk deeper of the GNU radio here with the data type. The signal processing blocks communicate with each other via the data stream. The GNU radio requires that the input and output, the input of the output of the first data block must be matched with the input of the second blocks. It means that, for example, here, the output of the source 1 and source 2 must be matched with the input of the adder, and the output of the output data of the adder must have the type with the same with the output data with the FFT, the oscilloscope, and the speaker in order for the system to work. Here we have, for example, here we have 5 types of data. We have the byte, the int, the complex, the short, and the float. And also in the GNU radio, we also name the blocks at the end with the type of the data at the input and output. For example, here with the block N with dash F, it means that the input and the output of that block is the float. And here we have the input is the float and the output is a complex. With this block, we will see that the input is the vector, the input and the output is the vector of floats. It means that the output is the parallel data stream with the length, with the number of bits or number of floats equal to the length of the vector. And here we have input and the output is byte. Similarly, we have the integer and the short. So in order to use the USRP2 with the GNU radio, here's the code for that. This is a USRP. In this line, we want to use the USRP2 at the source. For example, we want to receive the Wi-Fi signal, then we will receive the Wi-Fi signal from the USRP2 and send it to the GNU radio to process. The USRP2 uses the gigabit Ethernet, so we have to define the interface of the Ethernet that we connect to on the computer and the MAC address of the NIC card. And in the second line, we want to use the USRP2 as the sink In this case, for example, we want to send out some Wi-Fi or some wireless signal. In this case, we have to, if we want to use the USRP2, we have to define the USRP2 as the sink. We also have to define the interface and the MAC address as the same as the upper command. And how to connect them with the other blocks in the system. The order of the command is from the left to the right. It means that here the U stands for the USRP2. If you want to use it at the source, you should put it on the left of the command. Here you connect the USRP2 with the other block. And if you want to send some signal from other blocks to the USRP2, and from the USRP2 you will send it through the air to another system. So you should put the USRP2 at the end of the command after all the other blocks. So in order to use the USRP2 properly, we should define all the parameters for it. For example, here we want to use the USRP2 as the source. So what should we do? The first thing that we should define the USRP2 as the source, and then we should set the decimation rate of in the case that the USRP2 is a source, or the interpolation rates in the case that the USRP2 is a sink. And then we have to set the gain of the USRP2 or the gain of the antenna that connect to the USRP2. And also you have to set the frequency that you want to transmit the signal. And after you have all these parameters, you can connect the USRP2 with another block. Here are some useful blocks that you can see with the source. You can use the USRP2. You can use the audio file. And you can use a file, the sinusoid or the noise. We have the Gaussian noise, for example, with the sink, because there with the sink we also have almost the same as the source, the USRP, the audio, the vector, the FFT, and the phi. And here we have the filters to filter the signal. We have low pass or high pass filter, the band pass, the Hilbert, and so on. The race goes in. So in order for you to understand all the theory, all the knowledge about the USRP2, I will try to explain to you the FM receiver code that I use that from the GNU Radio